Looking at our final review for the final test, chapters 1 and 2, the first question is asking us to solve this rational equation. And our easiest technique was to take the whole equation and multiply by the LCD. So if we look at how this would factor, we would get x plus 3 and x minus 2. So our common denominator would be that x plus 3 and x minus 2. So if we multiply every single piece by that, in our first piece, the x plus 3's drop out, and we have 6 times x minus 2. In our second piece, the x minus 2 would drop out, and we would have the 5 and the x plus 3 left. And on the final piece, everything in the bottom cancels with the x plus 3 and x minus 2, so all we have is a negative 20. And now it just becomes a regular linear equation to solve. So distributing, we have 6x minus 12 minus 5x minus 15 equaling negative 20. Combining like terms, we get x minus 27 equaling negative 20. And if we add the 27 over, we end up with x being 7. And then we always want to check to see if it works. So we would look at our original equation and make sure that 7 doesn't make anything undefined. And if we look in the denominators, the only restrictions that we would have had was that x could not be a negative 3 or a positive 2, because if we dumped those back in our equation, it would create zeros in the denominator. So this x equals 7 should work fine. Question 2. A computer repair shop charged a customer $271 to repair a laptop. The bill listed $91 for parts, and the remainder was for labor. If the cost of the labor is $45 per hour, how many hours of labor did it take to repair the computer? So total bill was $271, and that's split into pieces. We've got parts plus the labor. Well, parts was just a flat fee of $91, but the labor, we are told it's $45 per hour for X hours. So we're really solving the equation 91 plus 45x equals 271. And if we subtract the 91 over, we have 45x equaling 180, and when we divide, we get x equals 4. So there would have been 4 hours of labor being charged to that customer. Question 3 says to solve and graph. We have an inequality, a compound inequality here. We want to isolate the x. So the first thing I would do to get rid of this negative 4 is I would add 4 to everything, all right, to all sides. So I'm adding 4 to the negative 6 side, I'm adding 4 in the middle, and I'm adding 4 on the end, okay? Combining like terms, we end up with negative 2 is less than 1/2 x, which is less than or equal to 1. And now I can times everything by 2 to get rid of the 1/2, and I end up with negative 4 is less than x, less than or equal to 2. Now we had some new notation this year. We showed that with squared brackets and rounded brackets. So we could also say our solution is the interval from negative 4 up to 2. We can include the 2, so we would use a squared off bracket for that, but we cannot actually equal the negative 4, so we have that be a rounded bracket. And then for our graph, it just looks the same as that interval notation. We have a negative 4 and a 2, and we said squared off at 2, rounded at negative 4. And we could have x be anything in between. Question 4 says to find and write the result in standard form. We have complex numbers here, so we are going to FOIL this out. 11 times 11 is 121. Outsides gives us 55i, and insides gives us negative 55i. So those are going to cancel each other out. And then our last term is the negative 5i times positive 5i, which is negative 25i squared. But I squareds are defined to be negative 1, which turns that into a positive 25. So we really have 121 plus a positive 25, or 146, once the insides and outsides are canceled out. All right, question 5. We are solving an equation that has a fraction or rational exponent. First thing you want to do is isolate anything that's being raised to that power. And in this first example here, we already have it that way. So our next step would be to take both sides and raise them to a reciprocal power. So we're going to raise this side to a 3/2, same with this side. Okay, now on the left side, the 2/3 power and the 3/2 power cancel each other out. We just get x plus 5. On the right-hand side, we have to understand what that 3/2 power means. And the bottom number is your root. So we're doing a square root here. And the top number is your power. So we are cubing. Okay, so we need to take the square root of 4. And remember that anytime you take a square root of a number, you have to include both a positive and negative root. And then we're going to cube that answer. So the square root of 4 would be positive or negative 2. When we cube it, we get positive and negative 8. And then we can simply subtract our 5 over and simplify. So negative 5 plus the 8 would give us 3, and negative 5 minus 8 gives us negative 13. So we get 2 solutions there. All right, moving on to chapter 2. The first question says to graph the parent function and then use transformations of this graph to graph the given function here. So looking at our function, we have an x squared here, which means our parent function is just y equals x squared. So graphing that, we have 0.00, 1, 1, 2, 4, and then the opposite side, negative 1, 1, and negative 2, 4. So those would be the points for our parent function. And then we have to identify the transformations. So the first thing I see is this 2. That is a vertical stretch, which means all of your y's are going to get doubled. Okay, twice as big. And then we have this 4, which would shift everything right 4. And the minus 3 is going to move everything down 3. All right, so looking at our graph, let's start with our vertex at 0, 0. Doubling it doesn't do anything. Double 0 is still 0. But we can move it right 4 and down 3, and it lands there. All right, taking the next point, 1, 1. Doubling our y value puts it up at 2, and then moving it right 4 and down 3. Puts it here. Taking our next point to the 2, 4, doubling it would put it up at 8, and then right 4 and down 3. Lands us there. And then we can do the same with the other points, or we could look at that line of symmetry and just use the fact that both sides have to be symmetric to get our other 2 points here. And draw it in. And because there was a 2 in front, it should look narrower than the parent function, and this one does. Second question says to determine the domain and range from that first question and to use interval notation to answer it. So domain is everything. We can use any x's, positive, negative, 0. So for my domain, I'm going to say from negative infinity to infinity. I can use everything. But my range has a cutoff. So right down here is the lowest point that my graph is going to ever get. All right, and that's at negative 3. So we would say my lowest point is negative 3, and it's going to keep going for y values up from there. Question 3 asks us to identify where is the graph increasing and decreasing. And most students get mixed up because they focus on the y values. Instead of looking at, when we talk about the interval, we're looking at what are the x's where my graph is increasing and where are the x's where my graph is decreasing. So again, there is a change that happens right here. So the break on my x-axis would be at 4. So everything that's happening to the left of that 4, from negative infinity all the way up to 4, when I look at my graph, my y values are going down. So I would say my graph is decreasing in that section. So I'm decreasing from negative infinity to 4. But if I look at everything on the right-hand side, now my y values are going up as I move to the right. So from 4 to positive infinity, my graph is increasing. So you really want to look at where is there a change in what your graph is doing, and then bring that up to the x-axis to see where your intervals are going to start and stop. And our last question here is asking for you to do a composition of 2 functions. That's where we plug one function into another function. And the order is really critical here. So this one says we're going to start with our f function, and g is going to get dumped in. All right, so we're going to start with f of x, which is 3 times something minus 4. And then we are going to dump in our g function, which was x squared minus 2x plus 6. And then it's just a matter of simplifying. So distributing, we would have 3x squared minus 6x plus 18 minus that other 4 gives us a function of 3x squared minus 6x plus 14. The second option here is just the reverse. It says start with g and dump f into it. Okay, so we're going to start with our g function, which is something squared minus 2 times something plus 6. And where those somethings are, we're going to dump in our f of x function, so the 3x minus 4. And again, now we just have to do some simplifying. Be careful when you take 3x minus 4 and square it. We are really taking 3x minus 4 times itself. So if you don't remember the shortcut, you do need to FOIL it out. 3x squared would be 9x squared. Insides and outsides both give us a negative 12x, which gives us a total of negative 24x. And then negative 4 times negative 4 is 16. Distributing our negative 2, we end up with negative 6x plus 8, and bringing down our last constant there, 6. And combining like terms, we get 9x squared. We have negative 24x and negative 6x, so negative 30x. And then we have a positive 16, a positive 8, and a positive 6, which gives us a total of 30. All right. There is a worksheet that has photocopies from your book that has the questions here for your homework on. If you don't have that worksheet, you can certainly look in your book and do the problems listed here.